Welcome to Mr. Tompkins Ed Tech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers cumulative frequency curves. I've taken related questions from my past paper walkthroughs and given them to you here back to back. This series is intended for the last few weeks of your revision, and my advice is to go through all the practice papers and past papers before you look at these, or the compilation videos will be the mathematical equivalent of endgame spoilers for you. Having already worked through all the practice papers, these compilation videos will give you a deep dive on topics you are still finding challenging, give you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it.
Question 18 gives us a frequency table, well, a group frequency table, and we need to draw a cumulative frequency graph to go with it. Now, in order to draw a cumulative frequency graph, we're going to need cumulative frequency. They've handily left us a column on the end here to calculate it. Cumulative frequency goes in here. We already explained this earlier, but that one is going to be the same as that. The next number you get from adding the number above with the number to the left. So this one here is going to be 9, and then the next one is going to be 44, next one is going to be 74, and then 84, 92, and 100. And when you get to the end of the list, always a good idea just to check that you've got the same number as you should have. They haven't told us how many we should have here, but it's a nice round number, so I'm happy with that. Okay, so now we've got this, we're going to be plotting cumulative frequency, these values here, against upper class bound. We're going to be plotting them against these numbers. Okay, so the first point I need to plot is 80 against 0. So 80 goes with 0. The next point is 9 goes with 100. So 100 goes with 9, and so on. I'm going to plot all the others. So I'll pause this, plot the others, and get back to you. Okay, having plotted all my points, now I need to join them up with a nice smooth curve. It's kind of easier said than done on the computer, but I'll do my best. Try and pass through the center of each of the marks that you made. Okay, that's alright. So you tend to get this S-shaped curve with cumulative frequency. If your graph starts heading downwards again, obviously you've made a mistake. Right. Estimate the number of these films with a running time of less than 2.5 hours. So 2.5 hours is how many minutes? That's 150 minutes, isn't it? So what we need to do is read up from 150 and across. So let's get the ruler out, put it on 150. Oops. So we're going to draw up from the 150 until we hit the curve. Right, okay, so this value here is 82. So estimate the number of films have a running time of less than 2.5 hours. It should be 82 films. Question 8 has a group frequency table showing the travel time that 80 teachers took to get to work, and we're being asked to draw a cumulative frequency graph of this data. Now, cumulative frequency is where we plot the upper class boundary against the cumulative frequency. So we're going to class upper boundary, which is 20 in this case, and 40 and 60 and 90, and we're going to plot that against cumulative frequency, which is 12 plus, we add those two together to get the next one, which would be 44, and then we add all three together, or 44 plus 25, to get the next one, which is 69, and then finally 80. It's always a good idea just to check this last value matches with the total they give you in the actual question. So that looks good. I'm going to plot those points then on my graph. So 20 versus 12. So 20 goes with 12, it goes there. The next point is 40 with 44. So 40 with 44. We can plot 60 with 69. 60 and 69, it's going to be there. And then finally 90 with 80. So 90 with 80. Now we can also plot another point. We can plot the lower class boundary here against 0. So I can plot one at 0, 0 as well. So my graph actually starts there. Now I'm going to join those up with the distinctive kind of S-shaped cumulative frequency curve. Try and make sure you use one continuous line passing through the center of each of the marks that you made, like that. Right, and then the next question says, estimate the number of teachers who took between 50 and 70 minutes to travel to work. Okay, so 50 is here, and 70 is here. So in order to do that, we're going to have to read up to the graph at 50 and 70 and find out how many teachers that represents. So just join up to the graph. 50 and 70, and then across. Now we can see that we've got values 58 and 74 there. So number of teachers, it's going to be that, well, it's going to be the distance between the two of those, the distance from there to there. So it's going to be 74 minus 58. Which is, no it's not, it's 16. Question 15. 60 people take part in a quiz and the graph summarizes their score. Now you can see we've been given a cumulative frequency curve with all the marks on it. And we're asked to use the graph to estimate what fraction of the 60 people scored more than 30 marks. Now here's 30 on my graph. Now to work out how many people scored more than 30, first off we need to look up from 30 along our graph. So I'm going to use a ruler and show that. It's going to mark on reading up from 30. It's a good idea to show your work in this way because it counts as method, and then along from there, and I can see then that, what mark is that? Each one of these little squares is worth 2, isn't it? So 10, 12, 14. It's halfway between 14 and 16. I'm going to say that's 15. So I'm going to say that 15 people scored 30 marks or fewer. Now if we want to work out how many scored more than 30, then actually what we're looking for is the people from there to there. So the number of people there are between the mark 15 and 60. So I would estimate that as 60 take away 15, which is 45 people. So writing that as a fraction, for some bizarre reason this is asking for a fraction, so 45 sixtieths of the people, which I suppose we can cancel down to 3/4 of the people scored more than 30 marks. Okay, part B, estimate the median score. Okay, now the median score is at the halfway point. If you've got 60 people, then the median is going to be 60 plus 1 over 2. It's the 30.5 value, which we can read off from our graph again. So coming back to our graph, we need to read across from, well, 30.5, but I might as well just read across from 30. So again, reading across the graph in the other direction this time. So along from 30, and then change direction, go downwards. Now I estimate that to be just slightly below 70. I'm going to say that it's 69. So estimate the median score, 69. For now. Question 15C, the same people take part in a second quiz. The graph summarizes their scores for both quizzes. So we've got our original curve quiz 1 and our new curve quiz 2. Jack states the quiz was easier than the first quiz because the graph is higher. Does the graph support this statement? Give a reason for your answer. Now, though at first glances it might appear that people would have done better at quiz 2 than quiz 1. That's not actually how cumulative frequency graphs work, that the higher the graph is, the better that you're going to do. Now let's consider what we just did, finding the median value. So if I read off at 30 for both tests and find out what the median is for both of them. So we've got two values that we can look up here. So the median for the second test is there, look. And for the first test or quiz, it was up here. We said it was 69, didn't we? So we said this one was 69. Now we can see that the median for quiz 2 is all the way down here. It's 19. So on average, people did a whole lot worse on quiz 2 than quiz 1. So was quiz 1 easier? I would say no. The median for quiz 2 was 19, much lower than quiz 1. Question 19. Here is some information about the marks for 60 students in a test. So we've got a group frequency table, and underneath it says, on the grid, draw a cumulative frequency graph. Okay, so cumulative frequency is upper class boundary against cumulative frequency. So upper class boundary is the highest value of each one. So it's these numbers here, isn't it? So I'm going to be plotting 50 against 9. I'm going to be plotting 60 against those two added together. 9 plus 16 is 25. I'm going to be plotting 70 against, well, 25 plus 20 is 45. I'm adding those together, aren't I? So my 25 plus my 20 gives me 45. And then I'm going to be plotting 80 against those, which is 45 plus 8, which is 53. And then finally I'm going to be plotting 90 against 53 plus 7. It's going to be 60. Always good just to check that this number here is the same as the one up here. It is, so I'm confident I've added up my cumulative frequencies correctly. Now it's just a matter of plotting. There's one other point I can plot. I can plot the lowest class bound here against 0. So my first point is going to be 40, 0. 40, 0 is going to be that point. My next point then is 50 against 9 and 60 against 25. So 50 against 9 and 60 against 25. Next 2 points, 70 against 45 and 80 against 53. So 70 against 45 and 80 against 53. And then finally, I've got 90 at 60. Okay, let's just zoom out a bit so I can see the whole graph. So you normally get a distinctive S-shaped curve when you plot in cumulative frequency. Might be a little bit hard to see here, but it's more or less there. Let's just join those up with a straight line. So you want to be joining these up with a smooth, continuous curve passing through the center of each of your points. And kind of topping out at your top value up there. Okay. Question 19b asks, use your graph to estimate the lowest mark of the top 20% of students. Now there were 60 students altogether, so the top 20% then, 20% of 60, well 10% of 60 is 6, so 20% is going to be 12 students. So we're looking for the top 12 students. So on our cumulative frequency, if we're going to have 60 at the top and we take away 12, we get 48. So that is where I need to read across from on my graph. So cumulative frequency of 48. Let's get the ruler out. I'm going to read across from 48 till I get to my graph. When I get to my graph, I'm going to change direction and read down. So it's there, isn't it? So what's that on my graph? That is about 74 or 73 and a half. So I'm going to round that up to 74, I think. So use your graph to estimate the lowest mark of the top 20% of students. It's about 74. Question 22. Here is some information about the miles per gallon of 60 cars. And we've been given the miles per gallon and the frequency in a group frequency table, and we've been asked to draw a cumulative frequency graph. Okay, now when we draw a cumulative frequency graph, we are plotting upper class boundary, which is these ones, against cumulative frequency. So let's just use this table here to work that out. So my upper class bound is going to be those values 50, 60, 70 and 80. And my cumulative frequency, well, my first cumulative frequency is the same as my frequency. My next one is going to be those two added together. 6 and 16 is going to give me a 22. Now my next cumulative frequency is going to be those three added together, but I already know the first two add to 22, so I just need to add the 28 to my 22 to get 50. And then finally that one there, I add all four together, or my 10 to my 50, which gives me 60. Always a good idea to just check that is the same as the answer that they give you at the top, because it is an easy mistake to make during a test. Okay, so now I've got my cumulative frequencies and my upper class boundaries. I can start plotting the points. Now there's actually an additional point I can plot first. I'm going to plot 0 against the lowest value there on my cumulative frequency table, my frequency table. So I'm going to plot 0, 40 as my, or 40 is my first point. So my first point is going to be here, 40. My next point is going to be at 56. So 56. Each one of these little squares is going to be worth 2, 2, 4, 6, 8, 10, isn't it? So that's going to be 6 there. My next one is going to be plotted at 60 and 22. So 60 goes with 22, is that point there. My next one is 70 at 50, 70 and 50, and then finally at 80 and 60. 80 and 60 goes there. Once you've drawn your points, you can join them up with a nice, smooth, continuous curve going through each of the points. Should give you that distinctive S-shaped cumulative frequency curve once you're done. Okay. Right, use your graph to work out the interquartile range. Okay, now the interquartile range is the range of the middle half of your data. So if I've got a cumulative frequency of 60, if I've got 60 values, then 1/4 of the way through that, 60 divided by 4, is going to be 15. So my lower quartile is going to be at 15. Let's just get a ruler out and draw on at 15. So drawing across from 15 until I hit my curve and then draw down. Should give me my lower my lower quartile. So it should be there. And then my upper quartile is going to be 3/4 through my data set. So times in 15 by 3 gives me 45. So again, I'm going to read across from 45 to find my upper class bound. My upper quartile. Spin that round. Yep. Okay, so that's going to be my Q1 there, and that's going to be my Q3, the upper quartile and the lower quartile. So I make Q1 equal to, what's that, 57? It's between 56 and 57. I'm going to go for 57, I think, and then the Q3 value looks to be 68. So then my interquartile range is going to be Q3 subtract Q1, which was my 68, subtracting my, what was it, 57? 57. 57, 68 subtract 57 is 11. So the interquartile range then is going to be 11 miles per gallon. Question 19. Type A batteries and Type B batteries were tested. The cumulative frequency diagram shows the information about the battery life of Type A. And we can see it's got one of those distinctive S-shaped cumulative frequency curves. Estimate the interquartile range for Type A. Okay. Now you can see that we've got altogether, we've got 80 batteries in this sample. Okay, now the interquartile range is the middle half of your data, so basically you need to look at the range between 1/4 and 3/4 of the way through your data set. So 1/4 of 80 divided by 4 is 20, so we're going to read across from 20 to the graph. So from 20, I'm going to read across to the curve and then switch down, and that would be our Q1 value. drawn along the ruler particularly well today. What's going on? Okay, now it's done it. So, and then 3/4 of the way through the day, O is going to be reading across at 20 times 3, 3/4. It's going to be at 60. It's going to be easier. Okay, and then when we hit the curve, we're going to switch and draw down. So my Q1 is there. Look, that's Q1. Lower quartile. My upper quartile is here. That's Q3, which is 3/4 of the way through. Q2 is the median. So Q1 is lower quartile, Q3 is the upper quartile, and then the interquartile range then is the distance between those. Interquartile range, which is Q3 minus Q1. So from my graph, I can see that Q3 is 1400 and Q1 is 1100, and 1400 minus 1100 is 300. Question 19b. Estimate the number of type A batteries that had a battery life of more than 1600 hours. Okay, let's go back and look at the graph. More than 1600 hours. Well, 1600 hours on my graph is here, look. So we're going to use our community frequency curve the other way around this time. So rather than reading across from the frequency and down, we're going to read up from 1600 until we hit the curve, and then we're going to change direction and read across. Okay, struggling to draw on this line today. Go on, stop being annoying. Okay, done it. Right, so what's that value there then? That reads to me like 76. So up there is 76. Now what does that tell me though? That tells me that 76 batteries had a battery life of 1600 hours or fewer. Okay? Now the question didn't ask me that, it asked me how many batteries had a life bigger than 1600. So it's not the 76 as my answer, it's my difference between 76 and the top, which is 80. So the difference between 76 and 80, those batteries had a life longer than 1600 hours. So it's going to be 80 subtract 76, which is 4. So it's going to be 80 subtract 76, which is equal to 4 batteries. Okay, now part C says the box plot shows information about battery life of type B. On average, which type had the greater battery life? Tick the box. Well, the greatest battery life is going to be given by the median here, I suppose. So it's like the average life expectancy. So here the median is the Q2 value. It's the one in the middle of your box plot, and if you read down you can see that it's 1300. So type B has a median value of 1300. So let's compare that with the median value for type A then. Going back to the graph. Now we didn't work out the median, we worked out the lower and the upper quartiles. Now we can find the median by looking across from halfway through the values. So again, reading across from 40. Ruler, what's up with you? Okay, let's draw in again now. And then switching around and drawing down.
Okay, I can see my Q2 value, or median, is there. So I read that to be, what, 3 out of 5 little squares up from 1200. So if there are 5 little squares between 1200 and 1300, which is a span of 100, then each little box is worth 20, then, isn't it? 20, 40, 60, 80, 100. So 3 little boxes is going to be 60. So I read that off as 1260 as the median value from type A. So we said that type B is a median of 1300 and type A has a median of 1260. So B is the biggest medium, isn't it? So what do we have to tick? On average, which type has the greater battery life? B does. State how I chose my answer. Well, I've shown that. That's all fine. I've done everything. Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.